Hello and welcome on our tour of functions. So this is chapter 1, section 1, functions part B. We're going to be talking about evaluating functions today. So we're going to evaluate functions, absolute values, rationals, and radicals. So I'm giving you f of x, g of x, and h of x up above. We're going to start by finding f of 2. So we're going to take 2 and substitute it in for each x value. So I'm going to rewrite this down. And how I like to do it is I always put a parenthesis set wherever there is an x value. So I'm going to put this something squared plus 3 over 4 plus that something. And remember, I am substituting in this 2 to this function. Now, all we have to do is simplify this. So this 2 squared is 4, 4 plus 3 is 7, and then 4 plus 2 is in fact 6. So my answer to this is 7, 6 for f of 2. Now, the nice thing about this is if you type that into the calculator with a fraction button, you can literally copy and paste this and put any number on top of that really fast. So it's very, very useful. And it's another way, if you don't put the parenthesis set, if I put -2, you will probably make a mistake because that would be totally incorrect. If you do it with a calculator, you ended writing it down, it is totally incorrect as well. So let's find g of 8. So this is, again, how do I say this? This is the value of function g at x equals 8. And now I'm plugging in 8 into this function because g is the name of this one. So like I said, I like to do wherever there is an x value, I put a parenthesis set. So I'm going to write everything down except for the x and just a parenthesis set there. And let's plug in positive 8 here for that. Now, if I evaluate that, we start with inside of these absolute value symbols. They're like parentheses. So we're going to keep order of operations just the same as if they were some sort of bracket or grouping symbol, which they are. So now we can multiply here first. So what is -3/4 of 8, which is in fact -6. So I could rewrite this down as the absolute value of -16 and -6. We can simplify that to the absolute value of -22. And because it's an absolute value symbol, it just says, hey, whatever that is, make it positive. So our answer is positive 22. Our last one here is just doing the same thing, but with the square root symbol. So 3 plus the square root of x, again, as parentheses, plus 18. And again, I will be substituting in -2 here. And I can evaluate that as 3 plus the square root of, well, 18 minus 2 is 16. Or we all know that is 4. So this ends up being 4 plus 3, which is in fact 7. So example 2 is evaluating a rational function as well. So we kind of did something like this. We're going to do h of 2. So again, we're substituting in 2. So let's look at h. So h of 2, we'll put wherever that x is there, is equal to 4 times x, which is parentheses, and then 4 times x on the bottom, and minus 11. Now, you might be thinking, why don't we just cancel those out? And our answer is just 1 over -11. Well, that does not work. There would have to be a common factor of 4x in both of the bottom terms in order to do that. So, and I'll just show you, it's not 1 over -11. It's not that simple, because if I plug in 2 and plug in 2, we get this as 8 on the numerator, and the denominator is 8 minus 3, 8 minus 11, which is minus 3, or that -3. So again, if I thought about just canceling those, I would get 1 over -11, which is definitely not 8 over -3 or -8/3. So let's do a little bit bigger of a problem, or rational function, which again, these are a polynomial divided by a polynomial, if you didn't know what a rational function is. This is not very, very nice, but it can be. So let's go ahead and evaluate that. Again, how do I start at g of parenthesis set? There's going to be an x there that I am going to replace. We have, again, on top x minus 7, which I just put a parenthesis set, and that x squared, which I'm doing just a parenthesis squared, plus 10 times that parenthesis set plus 16. and we just substitute in that -5 for all of these. And if you did not use those parentheses right here, this would in fact be wrong because it would do 5 squared before it would subtract. So I'm going to move this up, and you can evaluate this very nicely. So -5 minus 7 ends up being -12. The bottom ends up being +25 minus 50 and plus 16. And then we can simplify that to be -12 on top and -9, which a simplified fraction ends up being +4/3. So please try this one on your own. One thing, if you get a weird square root answer, just leave it as is. So pause it and try yourself. So if you tried it, you should get square root of 17. Just leave it as is. Again, putting in 3, you get 15 plus 2 is 17. And you can't take a square root of 17 nicely. Should get 1/2 for this one and -5 for that one. Now, what if I'm not super nice and I'm plugging in more than just a number? What if I plug in a variable expression into that function? Well, it's not that bad. The next one is a little bit more tricky, but this one is not too bad. Again, same steps. I'm saying g of, I'm plugging in a parenthesis set where I have x's is equal to 3 times parenthesis set plus 4. Again, I am plugging in z minus 2 and z minus 2 to this. And then I just have to do some algebra like distribute here. So we get 3 times z and minus 6 plus 4. Combine my like terms of those. So we're left with 3z and minus 2 as my final answer for g of z minus 2. So our very last question before I have you check one is the same thing, except what if I throw a x squared or x cubed or whatever into it? Again, starting the same way, g of something is equal to -3 times something squared plus 2 times something. Again, evaluating this at x minus 5, plugging that in as my input. Now I'm trying to see what my output is. Now, this is where a lot of people will make a mistake. We need to recall this is -3 times x minus 5 times x minus 5. It is not x squared plus 25. That is incorrect. And then this one is just nicely as 2x minus 10 when I distribute. So I'm going to have to multiply this out by distribution, and then I will have to distribute in that -3. Or if you really wanted to, you could distribute it in the -3 first and then distribute it all out. It is up to you. I'm going to keep the -3 in front and know that this is x squared and then minus 10x and then positive 25. I'm skipping the step where you have x times x minus 5x, which is -10x. I'm not writing the 2 steps in between. You're in pre-calculus, you should be able to do this, I hope. And then it's plus this 2x and minus 10. And then almost our last step is, hey, now we can distribute that into all of those. So -3x squared, positive 30x, and then minus 75, and then plus this 2x and minus 10. Now it's just simply combine all of the like terms. And we should get our final answer of -3x squared. We combine the x's here, so it's plus 32x. And then we have a -75 and a -10 to get -85. So this is my finalized, simplified answer. So go ahead and please check on your own here with g of x plus 3, see what you get. I will have an answer after you pause it and try it. So hopefully you got this. Just notice that the 8 doesn't really do much. It just stays there. You just have to simplify the bottom, just like we did on the problem before. And if you plug in x plus 3 into those and distribute it out twice and distribute out the third time and simplify by combining like terms, you should get that on your denominator.